Afternoon. Welcome to this launch webinar for a new website called Climate Solutions Explorer. My name's Ed Byers. I'm a researcher at the International Institute for Applied Systems Analysis, but this website is the product of a much larger project. And thanks for joining us this afternoon or morning from wherever you are. So I'll give a quick overview, just introduction about how this website has come about. Then we'll have a live demonstration from Mia Werning, who's been leading the development of the website and the interactive content. And then we can have a little bit of time for some questions. And then we've got three great panelists who have also joined us from the Engage project, and they've also worked with us developing the content related specifically to research from their countries or their regions. So Mariana, Zoe, and Saritha, we've been working together for a few years, and thanks for joining us, and we can have a more interactive Q&A afterwards. So I think the first Q&A can be more questions, technical questions about the website, and then a bit more after about the research. So just in terms of the Engage consortium, this is a consortium of over 30 partners, largely research institutes and universities based all over the world. And it was brought together under a Horizon Europe or Horizon 2020 funding project. It's coming to the end of this year, and is largely about decarbonization and mitigation pathways, and also largely in the selection of partners, there are obviously a number from Europe, but really tried to get representative and the best modelers and analysts from a lot of the largest emitting countries around the world, because their influence within their countries also in developing national mitigation policies has been important and insightful for the research in the project. And so very briefly about the Engage project, it's been going on for 4 years and is coming to an end at the end of this year, has been developing new generation of global and national decarbonization pathways, modeling based and quantitative, both short-term and long-term to 2100. A lot of these contributions taken up in the latest IPCC reports. They want to reflect the latest policy commitments that are ongoing and net zero pledges that are constantly changing around the world. Understand the feasibility of these different pathways and whether the assumptions that have gone into models can really play out in real life, and which ones may be easier or more difficult. Understand in particular impacts of climate change at the national level so that we can communicate the benefits of mitigation, and also understand co-benefits between mitigation policies and other sustainability objectives. And a lot of this is not just been done within the research, but really engaging with stakeholders, including policymakers and NGOs and the wider public. And so the product of today's webinar is really outward-facing engagement, which is this website bringing together a lot of the research products from the project. In terms of the website, we have 3 main components that Mia will take you through now. One is the Impacts Explorer, and is largely focused on climate impacts. It's like a big interactive Google map, and you can select different indicators to understand changes across the world. We have net zero stories, and these are more like interactive policy briefs, and they're written as an article and combine interactive charts, maps, data, and images. And then we have national dashboards for 191 countries, and also 11 larger regions that combine information on mitigation pathways and also the climate impacts for these different places. In terms of the data that's gone into it, the data is available to download Creative Commons license. It is still very much being checked, but there's a lot of data to be checking. And on the impact side, this combines a lot of synthesized information from the CMIP6 climate models and EasyMIP3 integrated assessment models, hydrological models. And this is the gridded data for a number of indicators, including kind of heat and precipitation extremes, hydrology, energy, land, and air pollution. And then we have these downscaled mitigation pathways. So these are long-term emissions and energy system quantitative pathways. And these have been done for each country that are downscaled from integrated assessment model based on four let's say scenarios. One is current policies. One is assuming the continued action towards the NDCs and then reduced, and then emissions reduction kind of towards 2 degrees, but not so progressive. Then there's a scenario that implements the pledges that were made at the Glasgow COP26 at the end of last year. And then there's a more ambitious Glasgow ++ scenario that has been developed within the project that builds on those Glasgow pledges, but quantifies what is more required to get us closer to 1.5 degrees. So lastly, before we move on to the exciting bits, there's a huge amount of acknowledgements to be made. A large team at IIASA that are working on this. Some of them on this call have been producing impacts data and mitigation scenarios, but also many other people around the project who have contributed data in producing the stories represented by almost all of the partners in the consortium, and very much a collaborative effort. So thank you for joining, and I'll hand over to Mia now for the interactive demonstration.
Thank you very much. Let me just share my screen. Okay, I hope you can see it now. So this is basically the landing page of the Climate Solutions Explorer. And as Ed has mentioned earlier, we have 3 big parts: the Impact Explorer, the Net Zero Stories, and the National Dashboards. And these different sections can be accessed either through the navigation bar on top here, or we also have links on the landing page to the different sections. So we have a link to the Impact Explorer here, to the National Dashboards here, and at the bottom you can see a preview of some of the stories and also get a link to see all the stories here. I'm first going to start with the Impact Explorer. And the Impact Explorer is showing the spatial maps of the different indicators that we've calculated. On the left, there's a big settings menu here where you can select the different indicators, and they are sorted into different categories that Ed also has quickly mentioned before. Currently, you can see precipitation here, but we also have 5 other ones that you can expand by clicking on them and then also removing them again. We also have the option to sort the indicators by sector. So if I select, for example, the health sector, I only get a selection of indicators relevant to this sector. In this case, this would be heat waves, tropical nights, and the air pollution indicators. This selection can also be removed again, and then you get the entire list of indicators back. Let me just select one indicator as an example. So for example, consecutive dry days. Then we also have more settings at the top of the settings menu. So we have the global warming level here right at the top, which is ranging from 1.2 degrees to 3.5. And you can select different options here to see how the indicator changes with different degrees of warming. In this case, it's not that obvious to see here. We also have a slider for the socioeconomics. This is only valid for the land data. There you can select the different SSPs. For the other indicators, that won't really make a difference. You can also select the indicator style in this drop-down menu here. What we're currently seeing is the absolute value of the indicator. So this is the indicator in the unit it was calculated in. In the case of consecutive dry days, you can see in the legend below here, that's days per year. You could also choose a difference, and this is then showing the relative difference between the global warming level selected and the historical period. And if I just change the temperature level again here, you can see that the difference is much bigger. It's much easier to see the difference between the different degrees. And then the third option that we have is the scores. The scores are always ranging from 0 to 3, which means that 0 stands for low impact and 3 stands for high impact. And these scores make it easier to compare different indicators to each other so that they're on the same scale. Speaking of comparing indicators to each other, we also have the option to add more tabs at the top here. So there's a little plus button on the right. And if I click that, I get a second screen here also with a settings window. And then, for example, we can compare consecutive dry days to wet days, for example. But you can also use it to compare the same indicators. So if I go to consecutive dry days here, and then if we look at both settings, for example, compare 1.5 degrees on the left to 3 degrees on the right. Or you could set it to the same temperature settings, so 3 degrees for both, and then say, oh, I want to look at the score on the left-hand side, and for example, the difference on the right-hand side to really compare the different values. You can also then remove the tabs again if you just want to go back to the default screen. There are a couple of more options on the right here. You can share the map on social media, you can put it into full screen, and you can also change the opacity of the map, which looks like this. Just put that back to full. Another feature that we have is that when you click on a certain country, for example, China, you get a little pop-up menu. And at the top here, you get a bit of information about the country, such as population, GDP, or the Human Development Index. And then if you scroll down, you see a chart showing the exposure of either the population or the land area to the 4 key risks for this country. You can also change it here from people to percentage, or look instead of different degrees of warming at the different SSPs. And so in this case for China, we see the top 4 risks here. The ranking that is shown here in the charts corresponds to the global ranking. So for example, for tropical nights, China would be the 3rd most affected country for this indicator. And then you also have the option down here to add more indicators. If you say, I want to look at something else, you can, for example, add the seasonality, and it will update the chart with an additional indicator added here. The next thing you can do in this dashboard or in this pop-out is there's a link to the national dashboard. Let me just click that and go there. So this will take you to the big dashboard for this country. At the top here, we have a selection list for all the different countries and regions available. As Ed mentioned, we also have regions such as the European Union or Latin America. But for demonstration purposes, I'm going to stay with China for now. And the national dashboards are again split into 3 different sections. So the first one is the overview page, which we're currently on. On here, you can see socioeconomic information, such as population and GDP, but also a bit of information about the emissions for the 4 different scenarios that Ed has mentioned earlier. We have a bit on carbon sequestration, which is only available for certain countries. And then again, we can see the key climate impacts. So the 4 we've seen previously, this case, we can see the impact maps, and you can select different levels of warming again here, and also change the selection of impacts here if you want to look at different things. If I go up now and go to the second point, which is the mitigation, that brings us to this big page here. So on the mitigation page, you can find lots of information about emissions, energy demands, energy supply, lots of different things, lots of charts, lots of data to look at. And all these charts that we have on these pages are interactive. So you can, for example, remove elements. If you just want to look at certain things, you can add them back in. If you hover over the charts, you get the values displayed for the bar you're hovering over. And all of these charts also have the option to save them either as an image file or also as a CSV, which will then contain the data that was used to create the charts. So yeah, as I said, lots of information on this page. And if you want to know more about the different scenarios that are shown on this page, there's also an expandable box at the bottom here. And if you click that, there's more information about the scenarios and also again about the SSPs. Let's then have a look at the final section, which is the impacts. And on the top right here, you can see again the chart showing the exposure by land area or population. In this case, it's not only the 4 key risks, but it's actually all the risks and indicators impacting that country. So for China, it's quite a long list. And then if we scroll to the bottom, we have kind of key risks selected in the 6 different indicator categories. So for each category, there are a couple of key impacts shown. The layout is the same for all. So you have a bit of text here with some information. Then on the right, you have the impact map at 2 degrees for China. And then we have 2 bar charts here at the bottom. So on the left, you see the exposed population, in this case, using an SSP population projection for the different degrees of warming, ranging from 1.2 to 3.5. And again, these are interactive, so you can disable certain elements to look at others. And then on the right, we have the avoided exposure by mitigating to 1.5 degrees. So this is showing the additional people exposed compared to 1.5 degrees, or in other words, showing how many people in terms of exposure could be spared by mitigating to 1.5 degrees. And as I said, we have that for the different indicator categories. So this was just an example for precipitation, but you could also look at energy demands or any of the other categories, and the design or the layout is pretty much the same for all of them. Which brings me then to the last big point, which is the net zero stories. This is the landing page for the stories. On the right, you can see an overview of all the different available stories in these tiles. And then on the left, we also have the option to filter these stories, either by country or region, and or also by topic. So if I say, for example, I only want to look at China to stay with our example, I can select this and I get all the stories related to China. And if I then say I'm only interested in energy security, I can filter that even more. So only 2 stories are available. And I'm just going to show one of them as an example here. The stories are all built in the same way. So we have the title at the top. Then there is a bit of information about the author and the institution on the left. You can find the key insights of the story on the right, and then the actual text and charts provided by the partners in the middle. Again, where possible, we try to make all these charts interactive. So we have a line chart here. We also have lots of bar charts in this example. And then for some stories, we also have national maps just showing, in this case, for example, air pollution. And I think this is everything I wanted to show to give you an overview of all the different features of the website. And I think with that, we're probably moving on to the Q&A then.
Sure. Yeah, if anyone, people do have questions, then yeah, please put them in the Q&A box, because I don't think you have access to the chat specifically, or people can raise their hand. Otherwise, hopefully the website is very self-explanatory, and we can also have more questions afterwards, but I don't see any coming in now. Okay, we do have a question. Can you download the gridded data? Yes, absolutely. Downloads the gridded data. So actually on the About page, maybe Mia can navigate that way. Just towards the right at the bottom, there are 2 links, and that top one there takes you to the gridded data. It's in NetCDF format at 0.5 degree spatial resolution. And then all the mitigation data is in an Excel format in the one below that. And also the top link there, which I said has it's called the hazards, impacts and exposure data. This also includes the aggregates of the so the number of people exposed to a certain impact within a country or a region. So this combines the spatial information and the kind of combined numerical information. Okay, and yeah, one more question. Is the website specifically for engaged data, or is it envisioned to include results from other projects or studies as well? Yeah, I can answer that also. Primarily, it would be, it's not entirely all engaged data in a sense, in the sense that some of the data sets that are used come from other projects. So the climate data, a lot of the impacts data derives from an ongoing long-term project called EasyMIP, in a sense that we have done additional post-processing to present it in a way that we want to. I think there's definitely possibilities to include information from other projects if it I think if it complements it, I can see that happening both in terms of the way that the stories are done. If people had wanted to suggest an article, but also if there was new gridded data that would be useful, that would add another indicator, I think there would be the possibilities to include that. So yeah, if you have suggestions, then please get in touch about that. And there are also, I mean, already, as I said, using information from other websites. So on the mitigation page about the emissions for every country, we have used information from World Resources Institute Climate Watch website that are really doing a great job in tracking the net zero pledges and the NDCs. And we both use data from their data set, but also link back to theirs so that you can see exactly the pledges that are being made in their database, or that are collected in their database. Okay, no more. One more question on impacts and mitigation page. Can I somehow select years, as well as what will happen in 2030 and 2050? I think the answer is no. Mia, do you, maybe actually if you take us to the, because I think some of the data is presented at years, but.
Yes, some of the data is presented, but it's not currently possible to select different years. But I would imagine that different years could be in the data that would be able to be downloaded. Yeah, and we're still experimenting a bit, I think, also with different different formats. So actually there, I think, I mean, we do see the exposure for different years. But yeah, also get in touch if the data is not, is that do that. Okay, don't see any more other questions, and so let's move on to the next part. And our first panelist, Mariana Imperio from the Federal University of Rio de Janeiro in Brazil. Do you want to share your screen, Mariana, or should we do it from our end?
Yes, I can do it here.
Okay.
Just try.
Thank you.
Can you see it?
Yep.
Yeah, now. So good morning, afternoon, and evening, everyone. Thank you, Ed, for the opportunity to present our work. So just a little bit of context. In the Engage project, we developed a lot of scenarios, climate mitigation scenarios, so NDC 1.5 and a lot of variations. And in our models, both the global one and the national one for Brazil, we usually see a lot of biofuels coming in associated with BAGS technologies. And in a previous study, we have seen that this use of biofuels, this type of biofuels, didn't reduce a lot of NOx. Actually, didn't reduce anything related to NOx. So we used the opportunity to have this platform or this tool to develop a case study for the transportation sector. And that's what I'm showing here. So this story, as Mia just said, is within the Net Zero Stories page, where we can see all the stories. And this one is particular for Brazil. So we did these win-win strategies for air quality and climate mitigation in the transport sector. And one thing that I like about this page is that you have all the key insights about your stories here. So some bullets about the context, some bullets about the results, costs, and so on. So you can have a really good overview of the stories if you read these key insights. You have a good summary. So I did here a bit of introduction. Then we show the GHG emissions for Brazil, just to give an idea about the country. So we did 3 scenarios: the business as usual, the NDC, and then the other one that was specifically for assessing this trade-off for Brazil, the NDC electric. I will explain it later. So we have the BAL scenario with lots of emission, then we have NDC going to 0 in 2050. When we take a look at the biofuels and CCS, both for NDC, actually for all scenarios, we see that in both NDC and NDC electric, where we enforce a bit of electric vehicles, not just for cars and motorcycles, but also for the road transport sector. So for heavy trucks and for buses also. We can see that we have a lot of biofuels being used, and they are also associated with the CCS, as I mentioned. So the lines are the CCS and the bars are the biofuels. And we can see that the blue one is the NDC scenarios. You have more of the biofuels, and the NDC electric, because before some electrification in some segments, we have a bit less of these biofuels, but still you have a great use of it. But especially you have the CCS that are being used to decarbonize the country and comply with the net zero target. Then if you have a look at the air pollution for the BAL and the NDC scenario, we have the first line here. The first 2 lines are the NOx emissions. The one at the bottom is the PM emissions, the particulate matter emissions. And for both scenarios, they are quite the same. So you cannot see here, but the 2 lines are together here. But for SOx, we can see some reduction. So from the business as usual scenario to the NDC, we can see some reduction because we are moving away from fossil fuels. We are using these biofuels. So we have a significant reduction in SO2. But if we look at the other pollutants, the NOx and the PM, we have the quite same amount of emissions in this scenario. So that means that the biofuels that are being used in the transportation sector are not reducing this air pollutant. And that's why we did this 3rd scenario, the electrification scenario, in which we are considering fuel cells also for the road transport sector, because these biofuels are mainly using for the diesel in the road transport. So we forced in the model to use these fuel cells that will reduce NOx and PM emissions. So we are showing here the reduction for both, for all the pollutants. So for NOx, we have a reduction of 55, I guess, something like this. For NOx, also for PM emissions, and much more for SO2. So you can see that this type of technologies for fuel cells for Brazil can have a benefit on the emission pollutant and air quality. So yeah, so that's pretty much everything. And also you can, as Mia just presented, we can see all the numbers here. We can, with the mouse on it, we can see all the data, especially when you have a lot of lines here, we can see the data also. You can download just as Mia presented. And yeah, that's all from my side. Thank you.
Great, thanks, Mariana. Okay, then let's move on to Zoe. Do you want us to share the screen, that we discussed?
Yes, I can share the screen. I can try to
oh, you
share
do.
it.
Okay, you do it.
Let me check. Okay, so hi everybody, and thanks for joining. It should work, right?
Yep.
Okay, so yeah, what we did here was to provide some input for the EU. So this was the national level analysis that is included, and it's one of the pillars of the Engage project and of this Climate Solutions Explorer. And what we wanted to do is assess the employment implications of the EU. And to do this, we employed a macroeconomic large-scale hybrid CG model, GEMI3. We assessed one central scenario and a scenario with some alternative carbon revenue recycling scheme. As Mariana said, I mean, the Explorer nicely allows us to have a quick overview of this analysis through the key insights. You can also explore by topic. So what we have indicated here as topics is really the economic impacts, employment and climate mitigation. And we have provided a short but informative overview of our analysis. And we go through first the, we opted to put first the sectoral implications of employment. We find that this is important, so one can go through the graph, which is interactive, download again the data, etc. And what we found here really is that after around 2035 or so, there can be net employment gains. So all the competitiveness implications are counterbalanced by the positive effects of substituting imported fuels with domestically produced ones. And most notably, we show that hydrogen, but also bioenergy and other clean fuels have a large potential for job creation, but also the power sector itself, power supply and transmission and distribution jobs will be created and will be maintained throughout the period to 2050. Now, I have to note that in these scenarios, we have not included CBAM, which is one of the measures to somehow mitigate the negative competitiveness effects that one could see from the climate neutrality action. So we see here that there are some negative implications for manufacturing sectors, of course, the energy intensive ones, but then also the rest of manufacturing, and of course, the fossil fuel industry. So whatever is related to, of course, coal production, but also the refineries as we know them currently. We have separated, let's say, the new type of refineries where bioenergy will be produced and the more traditional fossil fuel refineries, which will see some losses in employment. These are all changes from the reference scenario, and they are expressed in absolute levels. But we have also reported the macroeconomic implications. So the drivers of GDP, this is a transition that we expect to see a restructuring of the economy, going from OPEX to more like CAPEX type of economy. It's a technology and capital intensive transition. And yes, and so here again, we provide the composition of the GDP implications. And then moving forward, we again provide the employment implications on a sectoral level for the EU in the case of recycling the carbon revenues towards the reduction of labor taxation. This is a case that we know, for example, if we reduce social security contributions, this will reduce the cost of labor and thus can increase employment, but also have a positive effect on competitiveness. So this was one of the carbon revenue recycling schemes that we tried. There are, of course, more to consider, and some of those are more policy relevant, for example, related to the social climate fund, etc. But this one indicates that there can be double dividends already early in the period with job creation already from 2025, really. So this was a snapshot of the analysis that we did for the EU, and yeah, this goes under the climate neutrality stories of the Engage Climate Solutions Explorer. Thank you very much.
Great, thanks very much, Zoe. And then, yeah, so the last flash talk from Saritha, please.
I would like if Mia could share the India, because I think I may have internet issues. Okay.
Mia, you're muted, but yeah. So Saritha did a great job because she took on to do 2 stories. So it's been even more work, but there's lots of interesting stuff about
Great.
your studies.
I just wanted to ask which one you wanted first.
Water energy.
Okay, just a second. Let me just share my screen again.
And till Mia basically puts on the screen, I just want to give a background. So we basically part of this project as a national modeling team. So I wanted to thank the Engage project for encouraging national teams to come on board, because as a national modeling team, we are also learning at from a global picture perspective, where in my case, where India stands, and also from a modeling perspective, how we need to improve our models through a project like Engage. At the same time, we need to also focus on impacts of the decarbonization measures that are happening at for us at the developing country level. And here, this kind of database kind of also helps policymakers just give a brief, because not many policymakers would be interested to read our academic papers. So this kind of climate policy database kind of helps, impact policy database kind of helps for policymakers just to have a quick look at the various stories that we have developed at a country level, and look at different aspects, and also come to know about from a decarbonization perspective what is impacted not only from mitigation, but also for other systems, like not only energy systems, but water systems, and how it also impacts the air quality in case of India. So here I would, with that background, I would like to present first the case study on the impact of decarbonization measures on the water systems of India under NDC and low carbon scenarios. So to give a background, in the past 2 decades, India has witnessed almost 10 years. So in 20 years, almost 50% of the time, water stress. And in the next coming decades, this stress is always going to increase, which brings into the conflict between agriculture, industry, and power systems. And in order to see how in addition to, because we are having decarbonization measures, would these decarbonization measures affect the water systems? At the same time, would a water constraint system impact our decarbonization measures? And keeping that in mind, we basically ran the model aim and use, and we had the NDC and low carbon scenarios. Here we kind of showed that if in a non-water constraint scenario, our water demand is more than the water supply, as you could see in figure 1, it is more than the water supply limit that we have at 1100 BCM in 2020, 2030, 2050. So what we did was, what if there is a water constraint scenario? What kind of technologies need to come in place? What are the sectors that are impacted if there is a water constraint scenario? And what was the results that you could see in the figure 2 is basically agriculture was one of the most affected sectors when we have an emission constrained, water constrained scenario, which is followed by power sector. So there could be a lot of stranded assets because coal is one of the major coal power systems as one of the major systems that would be impacted by a water constraint or water stress, or especially during droughts, which could impact our electricity system. So doing this modeling, what we kind of are letting the policymakers know is, if there is going to be a future coal power system near a water stressed region, they need to have dry cooling systems. Wherever there is a water stress from an agriculture perspective, they need to move towards micro irrigation, drip irrigation to maintain our food security. At the same time, this paper kind of showed that if we have a development first, if we focus on our SDGs, on fulfilling our SDGs, we will be able to achieve our NDC targets. However, if we want to move towards the net zero targets, we need to have more policies in terms of water sector able to meet the decarbonization measures. So kind of give the snapshot of impact of water systems on energy and vice versa. Similarly, in the next story, what we tried to do was look at the impact of the decarbonization measures on the air quality and health in short, medium, and long terms. Here we did the scenarios where we tightened the air pollution control strategies, and we looked at the co-benefits from decarbonization measures on the air quality at a national level. So we looked at how decarbonization measures impacted the sulfur dioxide emissions, especially in the industry sector, the NOx emissions, especially in the industry as well as the transport sector, and the PM 2.5 emissions in industry, transport, building sector after 2030. And one of the things that is coming out is that in addition to the decarbonization measures, which do have an impact on the air quality specifically from large point sources, and also as we move and increase the electric vehicles even in the transportation system, we still require additional air pollution control strategies in order to be within the World Health Organization limits. So our national ambient quality standards need still improvement, and we need to have more strategies in addition to decarbonization strategies. So those are certain things which at a very quick glance through this policy briefs and the database we can come to know. And then if anyone's interested, you can go towards the paper that has been published. Thank you.
Great. Thanks very much, Saritha. That was lots to cover and really interesting. So yeah, if any of the audience still has questions, perhaps, I mean, both on the website, but also more thematically about some of the research that we've seen a preview of from Mariana, Saritha, and Zoe, please put it in the box. I had a question also that could get us going. I think one of the things that's clear in particular actually for these three different countries is that, and we'll see who wants to, who maybe wants to answer first, is that we have other externalities such as air quality problems that's affecting the local population, or in the case of India, it's water stress. And these are very acute problems for today, felt by many of the population. And we have identified within the research, you have identified big benefits. So kind of the mitigation of carbon emissions, whether it's transition away from coal or cleaner fuels in transport, or sectoral change, sectoral economic change that changes the job structures, can bring benefits to the population. And how, in your experiences, have you tried to communicate this with policymakers, both, I think, understanding short-term and long-term benefits of climate mitigation policies, and delivering co-benefits to other parts of people's lives? Either of you care to jump in with your local experiences on that? Yeah, go Saritha.
With our experience. So basically, as I had informed, when it comes to water stress, especially water is very much a local problem at city as well as village level. So one of the things that comes out is agriculture sector in India is an important sector when it comes to gross value added. Obviously, compared to services and industry, its value add is less. However, India has maximum more than 60 to 70% population employed in the agriculture sector. So here, water stress becomes a huge problem, and also it also may lead to food security in the future. So one, increasing water supply becomes important, and hence we not only say that we need to move towards technologies where we have to become water efficient. So India already has, like, for example, 20% water efficiency policy. Here, through the paper, we say we may want to have a 33% water efficiency policy, and we already have technologies. We just need to scale up those technologies. That's an example in water agriculture sector. In power plants, we inform them that you have to look at co-power plants which are in water stress region. We need to install either a dry cooling system. If we are employing CCS, that means there is an energy penalty in these power plants. So in a way, if it is in a water stress region, one, we say, please do not have CCS because there's an energy penalty to CCS. And second, if it's a water stress region, have dry cooling systems, which is, so those are certain things that we inform through these analysis. Similarly, air quality, when it comes to transport sector, we can always say from a large point source, the SO2 emissions can be reduced if we move towards a more renewable fuel mix, energy fuel mix. In transport sector, if we move towards electric vehicles, a lot of cities could be much more cleaner. And from PM2.5, so in building sector, from cooking biomass, LPG, and electric stove, specifically in urban sectors, electrification of cooking, and also district gas. We are basically reducing the PM2.5 and black carbon in the building sector. So there are a lot of benefits moving towards decarbonization, implementing the decarbonization measures in India, especially from a developing country perspective.
Thanks, Saritha. Yeah, Zoe, did you have experience about communicating this with policymakers? Otherwise, I would have asked you perhaps in relation to, in the modeling that you've done, understanding the changes from different sectors. Do you categorize in detail, for example, which are maybe more carbon intensive sectors and which are considered green or low carbon job sectors, job categories in doing the analysis?
Yes, thanks, Ed. Yeah, I mean, with regards to co-benefits, I think that in most of the cases, policymakers are indeed interested in understanding the wider co-benefits of one policy, and usually the policy ex-ante impact assessments are constructed in such a way that they can give inputs, for understanding the implications on different dimensions, policy dimensions. So employment is of course one of the key dimensions that policymakers might be interested in, but also air pollution, wider environmental implications, increasingly so biodiversity is also, a very relevant topic. Yeah, so I think that all these are very relevant to our assessments. Now, with regards to the modeling, yeah, we explicitly represent in GEMI3 all of these sectors that I pointed out, and actually in more granularity, we decided to put more aggregate sectors here on the Engage database. So apart from, let's say, the carbon intensity of a sector, which is part of our database, and this also to some extent determines how the sector will be impacted by climate policy. We also represent explicitly the clean technology manufacturing sectors. So, for example, wind turbine manufacturing, PV panel manufacturing, hydrogen, electric vehicles, batteries, etc. And this allows us to understand what are the opportunities in these emerging sectors in terms of employment, sectoral growth, etc. And of course, it's important to have this in the more like global context, to know how, for example, Europe would stand between other major players in these emerging markets. So one needs to understand, the market structure, and we have put a lot of efforts to this. And this is why, for example, we talked about job creation in specific sectors like hydrogen, bioenergy, or clean fuels, which have a large domestic component of the value chain.
Okay. Thanks. So then I'll just give a last question to Mariana before we wrap up. You want to escape without answering. So I thought it was interesting analysis that you had done from Brazil that both discusses benefits of electrifying transport. But one of the things was, because of Brazil being such a huge country and huge distances, it may not be as easy as in some other countries, and that you have other opportunities such as ethanol and biofuel production, but this would be better used in ethanol fuel cells, which is a less developed country. How do you think about this? I see this, it's a bit of is interesting, and it's a little bit different that maybe some other countries take. And at the same time, I see a bit of a missed opportunity in that Brazil has long had a very low carbon electricity supply compared to many countries, because it has always, or for a long time, been based on renewables. And so actually it would be a key opportunity to exploit electrification of transport system and really rapid reduction of emissions.
Yes, thank you, Ed. Actually, when we see the results for Brazil in the road transport sector freight transport here, as you mentioned, you have a long distance, so it's really hard to electrify this type of transportation. So what we usually do for Brazil is that we allow that light and semi-light trucks that they can be electrified, because they will run shorter distances. But for the long distance trucks, we apply the constraint in this specific scenario, the electrification scenario. We apply the constraint that these trucks could use fuel cells, both from hydrogen and ethanol. And what we saw from the results, because of the costs, the model chose the ethanol fuel cells. And here in Brazil, I think is a particular case, actually, because when we see the electrification of the light vehicles, so cars and motorcycles, we are electrifying these vehicles, and we are moving away from gasoline and ethanol. And here in Brazil, we have 27% of ethanol in the gasoline. So when we are electrifying these vehicles, we are using less ethanol in the future. And because of that, we have some ethanol available for other uses. So we can use it in the chemistry industry, you could use it in the fuel cells also. So that's why, I guess, in Brazil, we have this particular results, not using hydrogen ethanol specifically, hydrogen fuel cell specifically, but going to ethanol, just because we have such a huge production of ethanol, and we are not using that much because of the electrification of cars and motorcycles. So you have a lot of ethanol available, and then you could use it to the fuel cells. That's why it's a bit particular for Brazil, actually.
Cool. Yeah, thanks for explaining that for us. Okay, yeah, we've reached the top of the hour, so I don't want to delay the rest of people's days, but once again, thank you very much to our panelists for joining us and taking the time to explain their research and their experiences, also in contributing to the wider websites. Many thanks to Mia and the rest of the team here at IIASA that have been doing a great job in the development, and all of you that have joined the call. I hope that you enjoy the website, find it easy to use. There will be updates coming within the rest of the year as more stuff becomes available, and please get in touch with us directly also if you have questions or find issues, and happy to hear your ideas for further development. So yeah, on behalf of everyone, thanks again, and enjoy the rest of your day.